two variations of the basic frequency distribution are the relative frequency distribution and the cumulative frequency distribution. We previously worked an example of a basic frequency distribution, so we'll continue with that example and see how we would compute these two. So this was the data we had. We had 50 students who had taken an 80-point statistics exam, and these were their scores. And we had worked on our basic frequency distribution and computed the classes. We found the class boundaries, the class midpoints, and the class frequencies. And now we'll look at these classes again with the lower class limit, upper class limit, and frequency. That's what we need for these computations. Okay. So for the relative frequency distribution, we will calculate the percent of the data in each class. That's what we mean by relative frequency. How much of the data fell into the first class? Well, how many of the scores, in other words, how many of the students scored, what percentage of the students scored between 20 and 29? What percentage of the students scored between 30 and 39? So we compute that by knowing how many scored in that category. So the percentage would be, we had 50 students, 2 scored in the first class, so 2 out of 50, and we want this as a percent, so times 100, and we get 4%. So 4% of the scores were in the first class. So we'll call this our relative frequency for each class. Okay, so let's continue. 4 out of 50 scored in the second class, and so we had 8% of the test scores falling into the second class. 7 out of 50 in the third class, and that would be 14%. Then 10 out of 50 in the 40 to 49 class, which is 20%. 16 out of 50 in the next class times 100 gives us 32%. 8 out of 50 in the 60 to 69 class, that's 16%. In the last class there were just 3 out of 50, so that's just 6% of the scores in the last class, 70 to 79. And so we would want to check and be sure that we've accounted for 100% of the data. 4 and 8's 12, and 14's 26, and 20 would be 46, and 32 would be 78, 94, 100%. Now, if we had done these calculations and gotten decimals, done a little bit of rounding perhaps, this may not come out to be exactly 100%. It might be 99.9 or 100.1. That's okay if it's just a rounding difference. Okay, so a relative frequency distribution gives us the percentage of the data, in this case the percentage of scores that fall within each class. Okay, so we can use the same data now and talk about a cumulative frequency distribution. The cumulative frequency for a class is the sum of the frequency for that class plus all previous classes. So let's see how we do that. The sum of the frequency for the first class plus all previous classes, well, there aren't any previous, so let me get my column here. Cumulative frequency. Well, in the first class, then the sum of the frequencies of that class plus all previous, there are no previous, so that would just be 2. But now the second class, it says the sum of the class we have, 4, plus all previous, well, that was 2. So the cumulative frequency for the second class is 6. Okay, the sum of the frequencies for the 30 to 39 would be 7, the number there, plus all previous, which was 6. Now we're up to 13. Okay, for the 40 to 49 there were 10 plus all previous, so the cumulative frequency would be 23. Here we have 16 plus all previous, so we get 39. Then we had 8 plus all previous classes, that's 8 plus 39, 47, and now 3 plus all previous, and this one should be our total 50. The way we would use this information would be to for example, for the scores, I could easily see that 39 scores were less than 60 because they're in the 50 to 59, all the way up to 59. There are 39 scores that accumulate up to that point. So that might be important to note that 39 scores were below 60. A 60 out of 80 on a test is a 75%, so I could quickly see that 39 students scored below 75% on that test if you had 60 points on an 80-point test. So that's how this is helpful. You can quickly see, cutoff points and how many. And obviously below 79 or below 80, I guess you would say, all the scores were below 80, right? And that's what makes sense here. The cumulative frequency, this last value here, should be our N, the total frequencies that we were working with. So these are variations on the frequency distribution, more information that we can use to get a feel for the data. Notice that we can see something about the distribution either by looking at the frequency or the relative frequency here. We can see that in the lowest class we start out with just a few. It seems to build, reach a peak here, and then drop off. Notice it seems to build slowly and then drop off quickly right here near the end. So that just gives us a feel for what the distribution of the data looks like. And we can see that also with the percentages. We see it sort of build from 4 to 8 to 14%, and then our class that had the most of the data in it, the most scores, fell in that 50 to 59 class. So a lot of information. Take a lot of data and summarize it in these tables. You get a lot of information there in a manageable table.